is like where they're kind of alike, but they're not exactly alike. So congruent means they're exact same size, same shape, same everything. Let me give you a little idea about what a similar figure is. It's really easy. Where is it here? I'll go to star. So if I create that star, okay, and then I come out here and I get this star, and I come out here and I copy it, and then I paste it. Same dimensions, that's congruent, okay? Those two are congruent. Congruent means exact size, exact measurements, exact, anything you can measure on one, it's the same thing on the other. So let me just write that real quick. Okay, when it comes to congruent again, come on. This is congruent, exact same size, equal. If I were to come out here and let me paste another one. No, I'm going to grow it here. These two, these are similar. Okay, so you can kind of see what's going on here. Similar and congruent, they don't mean exactly the same thing, but they're related. They come off the same figure. So maybe this would be the original one, and this would be prime, and this would be double prime. Well, this one, the original one, and then I guess the first copy, congruent, same size. If I were to get this one right here, and put it on top of the other one, exact same size, okay? That's congruent. If I were to get this one over here, they are not the same size. My gosh, movie machine. Okay, but I'll tell you this much, the angles remain the same. Okay, any angle I put together or match up, like look at the corners right there. Okay, so we're going to keep that in mind as we do this lesson. So here we go. Use proportions to identify similar polygons, and we're going to solve problems using the properties of similar polygons. Okay, so here we go. Two polygons are similar if and only if the corresponding angles are congruent and corresponding side lengths are proportional. Okay, so what they're going to say now for the symbol is one squiggly line. That little one wavy squiggly line means that they're similar. Does it mean that they're exact same size? It means that they're similar. What that means again is that it has congruent corresponding angles and corresponding side lengths are proportional. So the way they named this one, A, B, C, D, is similar to W, X, Y, Z. The way the order, A is similar to what? W. So A corresponds to W. So those two right there, as far as A's measure of angle and W's measure of angle, exact same thing. Now, if you look from A to B, the side length. From WX, it's the same side length that corresponds to it, okay? Those two things right there, those two side lengths have a relationship. In this situation, can you see the difference? Or not the difference, look at the relationship they have. It's proportional, okay? Okay, if you don't see it, let's look at the next one. When you have two, you can kind of see it. Look at the angle B corresponds to angle X, and the side length BC corresponds to side length XY. Look at those right there. Okay. Now you got to be. This is going to be a STAR test question when it comes to 8th grade. I don't know how you want to kind of look at this one, but it's going to ask you several ways. Okay. Well, what do you mean, sir? If this is the original one, and then this is the new one, the prime, if this is the image, pre-image, and this is the image, the scale factor, that means how it's you know, how it's related to each other. From here to here, it's 1/3 the size. Okay, so you got to look at the words. The other way now, if they're asking you what's this one compared to that one, well, this one's what, 3 times this one to give you that one? So, again, when it comes to this one, it's saying that they are having a factor or a corresponding side have a ratio, a comparison of 3 to 1, 3 times bigger. If you look at it the other way, it's 1 to 3. Okay? So do me a favor, copy this down real quick. It's pretty important that you understand this stuff. It's pretty easy. It's pretty basic. Okay, and look at the similarities. The way it comes to the similarities, the idea, the way they name it is how they're similar. So you can say A first corresponds to W first, and then B second corresponds to X second, and third would be the C's, and so forth. Similar means that one little squiggly line. Okay, about 30 more seconds. Similar figures means that they have the corresponding angles are congruent. That means that they're equal measure. Corresponding sides have a ratio, a proportion idea, that they're all in proportion to each other. Okay, so again, I'm not going to compare, I cannot compare A to B to Z to Y. No, it can't be like that. I can't compare B to C to WZ. It has to be the corresponding sides, like AB goes to WX. BC goes to XY, and so forth. Okay, so let's come down here, let's check out this idea. As with congruent statements, the order of vertices is in a similar statement like A, B, C, D is similar to W, X, Y, Z is important. It identifies the corresponding angles and the sides. So let's come out here and use a similar statement here. So they're giving us triangle FGH is similar to triangle JKL. Okay, they're similar, guys. That does not mean that they're exact same size. It does not mean that they're orientated the same. Orientation means the way they kind of point, okay? If you look at this one, it's pointing up, and this is pointing to the right. Or you can see this one standing up, and this one's lying down, whatever. So F corresponds to which one? To J. So let me kind of move that up, get more space, and then let me go ahead and label this. F, this one right here, corresponds to J. G corresponds to K. And then H goes with L. Okay, so there it is. Pretty easy, not too bad. Okay, list all pairs of congruent angles and write a proportion that states the corresponding sides. So similarity statement, we're going to go up here, make sure you understand the order that they're given to us is very important. So that tells us automatically, we don't even need this, just FYI, we don't even need this. That tells us that angle F corresponds to what? Angle J, right? Angle G corresponds to K. Those are congruent. And angle H is congruent to angle L. Slash the ratios you see from here. I'll go FG goes to JK. FG, JK. Now, I can't tell you how to write this out, guys. I really can't. What do you mean, sir? Well, you could literally write this as JK over FG. Make sense? Now, I want to tell you this much. All of these up here, here to mine, I guess I'll go with triangle 1. And triangle 2. All of these come from triangle 1. All of these come from triangle 2. Okay? Same idea here. If I flip them all over, the ratios are still the same. So I can have here GH oh no, it's already KL over GH. LJ over HF. Now make sure you know that. As long as I set them up correct, I can set them up any way I want. Now when it comes to the star test, this will be on your star test in 8th grade. They can switch them around. They can even put the orders wrong. They can put this one right here, if they want, in the front. Because it's still true. Okay? So when I come out here and I look at these things, just basically go through it real quick, go through it slow, go relax. FG goes to JK. GH goes to KL. And then they went from H to F, so L to J. That's it. Now if you look at ours, we just set them up opposite and it becomes 2 over 1. Now I'm saying 2 as far as triangle 2's measurements over triangle 1 measurements. And it's still the same thing. Well, if I actually give you 1/2 is equal to 2/4, right? If I switch them over and I go 2 over 1, switch this one over, 4 over 2, it still holds true. Going once, going twice? Okay, go ahead and let's try number 1. Copy that one down real quick. Try number 1 real quick. Same idea. Let's just go ahead and name it in order, right? I'm going to cover the bottom down here. I think it gives us enough room. Okay, the diagram, this 4-sided figure is similar. One line means similar. Don't forget that. List all pairs of congruent angles in red, a proportion that relates to corresponding sides. So just in order, guys, like this, I'm going to go with angle N is congruent to angle U. Angle P is congruent to angle V. Angle Q is congruent to angle S. Angle R is congruent to angle T. Okay, that's it, right? We took care of the congruent angles. Now write a proportion that relates all the corresponding sides. Glad you could join us, Jai. Glad you could join us, brother. 30 minutes. So let's look at this one real quick. Honestly, you can go off of here if you want. It's up to you. Honestly, if you don't want to, I think it's way faster to go here. See? NP over UV. Pretty cool. See that one right there? NP, UV. Going once, going twice. I'm going to go PQ. PQ corresponds to VS. QR corresponds to ST. Now that's almost it. Now let me go from the last vertex to the first one, I guess. RN goes to the last one to the first. TU. So that's from this statement here, it says a lot. Okay. Pretty cool, right? Now this is actually showing me over here that this one right here is similar to that one. Somehow maybe half, 3/5. Something like that of that one, or vice versa. This one here is like maybe 5/3 of that one, or twice as big, or something. Going once, going twice. We're good. You have any questions over this part, guys? Okay, moving on. Hey, y'all know it's raining outside-ish or no? Or it kind of rained all night-ish or drizzled all night? How about that? Okay. This is very important, guys, this scale factor part right here. I don't like the way this book, it just leaves it like ambiguous, like, hey, which way are you talking about? I don't know which one it talks about most of the time. But when it comes to the star for the 8th grade test, this does come out in your 8th grade test, okay? This right here, your scale factor, will come out like 2 or 3 times, okay? Now, and when it comes from here to here, I'm going to throw some other stuff in it if you don't mind. Now, this part, this one would be like your original one, so this one right here. And then this one here would be your, I guess this would be your pre-image, and then this would be your image, or your new and your old. The way they name it in the star test is the direction they want. That means that this one came out first and this one came out second. So if you look at this one right here, since this one was named first for the 8th grade star, do you see how this one's the bigger one? and then it gets smaller, then you would look for the scale factor that's smaller, if that makes sense. That's for the 8th grade. Now, when it comes to this test right here, or this one right here, they're going to want you to name both. It's just whatever, just deal with it. It's not too bad, because it's either 1/2 or twice as big. But when it comes to the 8th grade, the order they name it is the order they want you to look at it. So let's go right here. The ratio of the lengths of the corresponding sides of two similar polygons is called the scale factor. Okay, so the ratio that we set it up, the scale factor depends on the order of comparison. So again, here they really just leave it open to interpretation. Is it this way or that way? I'm going to ask you when it comes to 8th grade, and I'll give you some of these in practice with direction. Oh, this one is 1/2 as big. You got it? If I'm asking the other way, then you better tell me it's twice as big. Okay, in the diagram, triangle ABC is similar to triangle XYZ. So it's showing you they're similar. When they're saying they're similar, guys, they have the corresponding angles to be congruent and corresponding side lengths to be proportional. The scale factor of triangle ABC to XYZ is 6:3, or 2. Okay, so look at the way they named this here. 6:2. Okay, that's the ratio they want you. The big one first, right, to the smaller one. Now, the reason they can compare these, if you look at this, this is not just given to us just by random order. They're comparing the sides that go together. AB, you see that? And then X, Y. So they can give me that ratio. They can use that ratio. I don't know the ratio if this 3 is over here. Well, what do you mean, sir? Well, when they show it to me here, they're using the sides that correspond to each other. They're using AB going to XY. Just FYI, I'm giving you a lot of making it harder already as it is. This one right here cannot be compared. I cannot compare AB to YZ. Okay? So when it comes to here, a good question will give you numbers all the way around. All the way around. And then they're going to say, what's your ratio? Well, you can't just jump around and pick any two numbers that look convenient, you know, like look nice together. You've got to pick the ones that correspond to each other. Okay? So here you go in the diagram. Triangle ABC is similar to triangle XYZ. The scale factor of triangle ABC to triangle XYZ is 6:3. Now, if you switch that order around, they're saying from XYZ to ABC, then it becomes a 1/2. Give me this one first, and then that one second. Going once, going twice. Okay, I want to throw one more thing in here for this one. So you all know how we do that paper, right? And then I go with congruent. And I put, what do I put here? Translation. Reflection. And then down here I put rotation. Now we're going to do the back side. Okay, the back side, this side is congruent. We're going to put not or non-congruent. Which sounds better, non-congruent or not congruent? Okay, we'll go with not congruent. And guess which one was going to go back here? This stuff here. Okay, we're going to go back here and put, we're going to call this dilations. A dilation, what do you mean? So it's like some of y'all that wear glasses, so they dilate your pupils, they open them up, they make it bigger. That's what we're going to be doing. Okay, so here we go. Let's look at this picture right here of Dalmatian. So look at this one. Kuma wants to use the rectangular photo shown in the background for her computer's desktop. Okay, so she wants to use this one right here somewhere. But she needs to resize it. Determine whether the following rectangular images are similar. So I guess this is the original one. And A or B, which one would be similar? Determine whether the following rectangular images are similar. If so, write the similarity statement and scale factor. Explain your reasoning. So first off, can you see these? We'll go with A and the original one, okay? Original. Now, when it comes to this one, you see this would be like my height. I'd have to compare it to this one right here. I'd have to compare it to that one. I cannot compare this one to this side here. It's just, you just can't do that. For A, let's see if they'll be similar, right? So I want to compare 8 over 12. Okay? What then I would do now is that equal. Does it stay in proportion to 10 to 14? Are these ratios the same? What do y'all think? Well, how do I see if this thing is true? How would you check if this thing is true, guys? Anybody know how to check if that's true? Calculate it up, right? You can put that in the action on the calculator and press enter, and it's going to say false. Or you can just cross multiply now. When I multiply here, I'm going to get 12 times 10 gives me 120. If I multiply here, it's going to give me 8 times 14. I'll tell you this much. 8 times some 4 ends up in a 2. Right? If that makes sense. Okay, then 80 and 32, what is that, 112? Are these things congruent? Let me see if my chat is working, guys. Is my chat working? Not congruent. So are these things similar? Not similar. See, this one and this one are not similar. Let me try this one out. These two are here. Again, I want to compare this side length to this side length. Okay? 8 over 12. Is that similar or in proportion to this one right here? 10 over 15. What do y'all think about this one now? Well, how could I do this in the calculator, guys? How could I do this in the calculator? Just put it in there, right? Press enter. Well, if you don't like that, I like cross multiplication, right? Pretty easy. That gives me 12 times 10, also known as 120. Is that equal to this part right here? 8 times 15. Okay, 8 times 10 is 80. All right? 8 times 5 is 40. So 40, yeah, it is 120. Boom. So guess what? These two things are in proportion to each other. Thank you, Matthew. They're equal to each other. Guess what they are? They are similar. They're not equal. They're similar to each other. They're not congruent. They're similar to each other. Now, I'm going to ask you something. If so, write the similarity statement and scale factor. What's the scale factor here? I know. That's the part I don't like in this book. What's the scale factor? Well, let's write the similarity statement. If you don't mind, let's write the similarity statement. I'm going to go A, B, C, D is similar. See how I went from this corner? A, B, C, D. I'm going to do the same order. J, K, L, M. J, K, L, M. Y'all okay with that one? Anybody get lost what I'm doing right there? Okay, so do you see how those two are similar? Okay, I went in that same order. Now, if we're going to go from the ratio, okay, from here to there, then just give me from here, this one first, to that one. What do you mean? Just get that side length from here. That corresponds to this one over here. And there's your scale factor. Guys, what's your scale factor here? Well, I don't know, sir. What do you mean? Well, this is my number, but we can't turn that in. We've got to simplify that up. It's 2 over 3. Your scale factor in this situation is 2/3. If I were to have written it the other way, JKLM, it's similar. This one comes first to polygon ABCD. Well, then switch it over, and I would have 12 over 8, right? Which now gives me what? 3 over 2. So again, the same kind of idea sets up. Which direction are you looking at it? Now I'm going to tell you this much. When this one gets bigger, this one's 3/2 of that one. This one now is 2/3 of that one. Pretty cool, right? Eileen was BK. You got it right, sister? Now, FYI, could I compare? I'm going to just come out here real quick. Could I compare this one to this one? Watch, look at this. 10/15. What is that? Divided by 5, divided by 5. Isn't that 2/3 also? Cool. That's what makes it similar. They use the same scale factor to come out here and give me the figure changed to some kind of other similar figure. They use a scale factor in this situation from here to here, 3/2. From here to that way, 2/3. Pretty cool. My gosh. Let's go. Okay. So 12.5. This triangle goes to 1 to 2, 10. Check. This one, Q to P, 2 to 3, 2 to 3, 9.2. Yeah, fix it, brother. Okay, so Eileen, it's true. So guess what we just checked there? We just checked this side, all right? And this side. Do we need to check anything else? What do y'all think? Do we need to check anything else? Yeah, we need to check the last one over here. Okay, let's set that last one up over here. 15 or 12. On this one here, you can go ahead and set all three of them up together, or you can just set these two up together. Since you know these two are equal, if this one's equal to that one, then by the transitive property, it carries through that all three of them are equal. So just check the last two real quick. Somebody, Eileen, thank you so much for helping us out this morning. Again, it's true. Somebody talk to me. Thank you again, Eileen. Next thing is, guys, do you see that? We now have that these two are congruent. We have that these two are congruent. So basically, they're all three congruent / not congruent. Yeah, proportional. We're going to go with the word proportional. So now we know that they are similar. So the similarity statement you want to write here is, ready? Triangle NPQ. NPQ. Why did I choose that one? And whatever, I felt like it. I can do any order I want. NQ, oh yeah, NQP. NQP. NQP, I went from angle 1 to angle 2. Angle 1 would be RS. RST. It's similar to triangle RST. What do y'all think about that one, guys? Not too bad. Now, what's my ratio? What is my scale factor? Now, stop what you're doing, guys. Which of these would you like to use your scale factor? I don't like that one. I don't like that one. Oh, yeah, I like that one. Why do I like this one? It has nice numbers to work with, right? Nice numbers. Nice numbers. You okay with that one? Now, just to keep my head sane, if you don't mind, if I were to go from this way to that way, it's going to be, okay, 15 over 12 is also known as 5 over 4. Do you agree? So if I were to go from here to here, that one's named first. For this group, we're going to go 5/4. You got it? Now, if I were to come back the other way, if I were to go back this way, since this one's named first, I'm going to go with 4 over 5. I'm throwing a lot in there. I'm going to go to 8th grade right now, okay, guys? Say this is the, we're going to go with pre-image, and this is image. The way they're going to ask you guys for this one, you're going to go X, Y. And how did it become this one? Do you see how this one's bigger, and then it became smaller? This is your answer. You see how it got bigger to smaller. Which of these is smaller? Cha-ching, right? This one's smaller. So this would be your answer. 4/5 x, 4/5 y. Pretty easy. What do you think about that one? Guys, we're going to call it quits there. I wanted to give you more time to do Alex, but it's about 9 minutes to the end of the class. Do any of you have any questions over this? I can't believe I talk so much. My throat is kind of like sore.